Thank you. That was a very generous introduction. Thank you. So I'm really thrilled to be here. And I'm going to sort of present a little bit of my work in progress. This is the fieldwork I did during my dissertation, but which I'm hoping to write up into some form of publication. So I would really love to hear your feedback since you're here in the thick of things. So I'm an anthropologist of science and technology. I study what people do with science and technology as experts, as users, as regulators, or whatever other roles you can think of. I try to understand not only what they do in practice, but also what it means for them and what it means for the world at large. So my talk today is really about data science as a form of expertise, and it's based on an ethnographic study I did of data scientists from 2013 to 2015 as part of the fieldwork for my dissertation. So you will not be surprised. There's been a lot of hype about data science. And again, I don't need to tell all of you that. So here's the Harvard Business Review calling data scientists the sexiest job of the 21st century. Here's HBR again saying that data science is going to reinvent what it means to be a manager. It's going to reinvent management. And then, of course, we can't finish the hype slide without the famous Chris Anderson article arguing that data science will change science forever by making theory obsolete. Of course, data scientists and other social scientists have pushed back on the hype. Data scientists have argued that what they do requires both data and theory, both programming and substantive expertise. So this, for instance, is the famous Venn diagram made by Drew Conway, which some of you might be familiar with, probably all of you are familiar with. And it shows data science as a kind of golden middle between programming skills, statistics, and substantive expertise or domain knowledge. Social scientists, for their part, have argued also that no analysis is possible without theory. And so, as the historian Jeffrey Bowker has put it, raw data is both an oxymoron and a bad idea. To the contrary, data should be cooked with care. Yet, we still don't quite know what data science is and what data scientists do, because we are all still in the process of figuring it out. So I'm just going to quote Stuart's line, which I found on the web, and as he puts it, we, by which he means both ethnographers of data science like me and him, and also data scientists themselves, don't know what data science is because we are still building and negotiating the institutions, infrastructures, and ideologies that will produce, support, and legitimize a professional class we call data scientists. And so in today's talk, I'll be trying to answer this call to describe what sorts of negotiations are happening in institutions around this form of knowledge production that we call data science. So I want to answer two questions in this talk. First, what makes someone a data scientist in the workplace, and what accounts for the power of this role in particular workplaces? And secondly, what makes data science both technically feasible and culturally desirable as a form of expertise? So, based on a 2-year ethnographic study of experts working in the world of massive open online courses, I argue that the power of data scientists hinges on their ability to situate other professionals with relevant expertise simultaneously as collaborators, as users, and as domain experts, and switching strategically and seamlessly between the three registers. Data scientists thus dictate the terms on which users and other experts participate in shared projects, incorporating potential rivals and effacing their own power. Data scientists are thus both hybrid experts and experts of hybridity. That is to say, data scientists view their work as hybrid and composed of multiple dimensions, often some combination of programming, statistics, and domain knowledge, and that they wield this hybridity as a source of power in workplaces and in their interaction with other experts. Paradoxically, however, this means that the role of data scientist is an open-ended one, and the role can be claimed by different experts within a certain field in the pursuit of funding, reform, or both, or something else altogether. So what I'm going to do is try to give you some evidence for these findings in the rest of the talk, and I hope you can give me feedback as to where I might be wrong or what I need to think more about. So in the rest of this talk, what I'll do is I'll first introduce you to my field site, the world of massive open online courses, or MOOCs. Then I'll talk about what it means to be a data scientist or to do data science in the world of MOOCs. I'll talk a little bit about the history and politics of knowledge production in the world of MOOCs. So that's the part where I'll give some evidence for what I just said before. And in the last third of this talk, I'll be a little more speculative. I'll talk about sort of data science as an example of something bigger, a sort of general and emerging form of expertise that I call platform expertise. And the third part is a little speculative, so bear with me on that. Okay, so first, massive open online courses. What I want to do here is sort of give you a sampling of what MOOCs are and what my fieldwork was. So I just wanted to do a poll. How many of you know what a MOOC is? All right, how many of you have taken a MOOC? Oh, great. How many of you have taught a MOOC? No, okay, so then that's good. I can give some background there. So as you know, the origin of MOOCs goes back to 2011 when two Stanford professors, Peter Norvig and Sebastian Thrun, released an AI course into the wild. This was not just course material. The course had lectures and machine-graded assessments, and if people finished them, they got a certificate. Almost 3 million people sampled the course, and about 35,000, I think, got certificates. So the success of this course inspired a flurry of other such courses from computer scientists at Stanford, at MIT, and by the middle of 2012, 3 new startups had emerged who would specifically build these types of courses. So these were Udacity, Coursera, and the place I did my fieldwork at, edX. And the courses themselves are called MOOCs, but these companies also sometimes tend to be called MOOCs. So the words kind of gets used interchangeably. Back in 2012, there was tremendous hype around MOOCs. I don't know if you remember, but it was going to revolutionize everything. But by 2015, by the time I left the field, the hype had died down, and it's died down even more now, 4 years later. And MOOCs are sort of comfortably ensconced in the higher ed space. So you'll see that there's lots of courses today. edX has more than 900. Coursera has, I think, more than 2,000. But the area, most people think that what MOOCs are going to revolutionize isn't higher ed in general, but sort of the specific field of corporate retraining and continuing education. And interestingly, you know, one of the cash cows of MOOCs is data science training programs. And so, but that's not the connection I'm going to talk about. Instead, I'm going to talk about what data scientists do to produce knowledge about education. But it's interesting because I think MOOCs are part of how establishing data science programs as well. But anyway, we won't be going there. So how do MOOCs work? The company I studied, edX, creates courses by collaborating with partners. So there's a very simple division of labor between edX and its partners. edX makes software, while its partners make pedagogy. And by pedagogy, I mean broadly courses, but also knowledge about education. edX today has over 90 partners who together produce more than 600. I think there's 900 right now. And these partners include everybody from higher ed institutions like MIT and Berkeley to companies like Red Hat and Microsoft to nonprofits like Amnesty International. So the kinds of courses these partners produce are very different. So, you know, Harvard will produce sort of, among other things, it will produce liberal arts classes, like the Greek hero class was very famous. Michael Sanders' justice class was very famous. Red Hat and Microsoft are often interested in making courses through which they can create certified programmers who will do Red Hat development or Microsoft development. And Amnesty's courses can be are often more like public service campaigns, like they want to create awareness through their courses. What edX does is that it provides its partners with a set of standardized software components and documentation, and then the partners are supposed to then use it on their own to produce pedagogy, to produce courses and educational research. So with you know, with more than 90 partners, this is really not a collaboration. edX is a platform that they use to produce pedagogy. edX also provides its partners with data, and I'll give you some examples of that, and dashboards, so that the instructors and researchers at these partners can quickly understand how learners are doing. So let me quickly just take you through what the work looks like on the partner side, because I think it will help understand when I actually talk about what data scientists do in this world of MOOCs. So again, this is like a tour. I'm not going to spend too much time on it. So when an instructor from a partner side logs in, they use this interface called Studio. Studio will give an instructor an access to like standardized course components. So here, you can have a discussion, you can have a problem, you can have a video. If you're good at coding, or you can also sort of select advanced and do some JavaScript coding to create your own custom components. One of the most sought after features that edX added, this happened sort of much later at around the end of my fieldwork, was an A/B testing feature. So what instructors or researchers or whoever on the partner side can do is that they can do content experiments. So for instance, if you have a particular course and you want to see if a video works better than just text to deliver the instruction, you can have half of your students watch the video and half of your students read the text, and then you can see how they do, so you know which one works better. So this is sort of what Silicon Valley people called A/B testing, but this was one of the most sought after standardized features that edX built for its partners, although this happened much later. And this feature we'll talk, I want to include this because it will come up again later. Instructors can also download stuff like grade reports. So for any particular assessment, they can sort of download CSV files to see how their students are doing, and they can analyze them if they want. And then lately, again, this happened much later, and you'll see why I give this graph. edX started to create dashboards for instructors and researchers. So this is the video analytics dashboard. It shows a video, and it shows how students watch the video. And you'll see there's a peak there at the arrow. So the idea is people are watching that part of the video a lot more. So maybe either it's exceptionally good or it's exceptionally bad. And you can go and find out, right? So this is something they learned from like YouTube and so on and so forth. And again, you'll see why I give all this. And then finally, of course, edX gives all its researchers and partners what they call the edX data package. So this is like the complete clickstream data, which every learner's click for the course. But that's not something you just get. There's a period of negotiations, and you get it sort of once every 3 months and so on. Right? And this is a huge, like a dump. It's a bunch of databases, MongoDB and SQL, and then just JSON file after JSON file. Anyway, so it's a lot of different stuff. OK, so that's just sort of what it looks like to make a MOOC. From 2013 to 2015, I was embedded at edX and 4 of its partners, MIT, Harvard, Berkeley, and Stanford. So when I was here at Berkeley is when I met Catherine for the first time. So I spent 4 to 6 months at each site. 4 to 6 months at edX, 4 to 6 at MIT, Harvard, Berkeley, and Stanford. At each site, I attended meetings if given access. I went to public and semi-public events. I talked to people informally. I did formal interviews. And I collected and read the voluminous documents that kept circulating. I made a conscious effort to seek out all the different organizational roles at each site, from the instructors to the video producers to the TAs to the support staff to the researchers. Anybody who had a different role, I tried to sort of get as many roles as possible, provided they talk to me, of course. In the rest of this talk, I'm going to, so the fieldwork was pretty broad, but in the rest of this talk, I'll talk in particular about those in this ecosystem who produce knowledge, broadly speaking. So this includes, of course, people who call themselves data scientists, but it also includes social psychologists, computer scientists, learning scientists, educational researchers, cognitive scientists, learning engineers, analyticians, or even just software engineers. And I emphasize this because one thing, as I'll talk about in the rest of this talk, you can only define what a data scientist does in relation to these other roles. So data scientist is a relational role. And so it's important that in the study, I wasn't just looking at people who already call themselves data scientists. I looked at a variety of people who sometimes use the data scientist label quite strategically. And I'll explain that later. OK, So with that introduction, let me now describe what it meant to do data science in the world of MOOCs. So this is going to be the longest section in this talk, and the third section will be pretty small. So what did it mean to do data science in the world of MOOCs? What was its history, and what were its politics? So let me get into that a little bit. I will argue here that the space of knowledge production in MOOCs, in the world of MOOCs, that little space in the middle, is a space between fields suspended somewhere between corporate data science, academic education research, and academic computer science. This means that those who work in this space of knowledge production in MOOCs are often from these fields, but they can also draw on the others flexibly. Furthermore, those who can draw on the resources of all three fields instrumentally and move fluidly between them are most likely to label themselves as data scientists. So this is sort of the claim which I hope to give evidence for in the rest of this section. So let me start from academic education research, which is roughly 100 years old. The historian Ellen Lageman tells us that education research has always been a contested territory and full of debates around the question of how does one create knowledge about education. Do you do it in labs? Do you do it in schools? Do you make the teacher part of the knowledge production process, or do you keep the teachers out of it? Are the teachers your collaborators, or do you just study them? Is the knowledge about education that is produced, is it pure knowledge? Is it applied knowledge? And part of the reason that these questions keep cropping up again and again throughout the 100-year history of educational research is that education is an inherently political concept. And American society has always been full of contests about the goal of education. New actors, we can call them reformers, have often drawn on these tensions to make an intervention in the field of education, or educational research. So in the early 20th century, behaviorist psychologists drew on their prestige to argue that education research must be done in the lab under controlled conditions. In the 1950s, in the wake of their newfound prestige vis-a-vis the Cold War, physicists and mathematicians argued that they were best positioned to understand what educational research should be. So this is in the wake of Sputnik, and everybody is worried that, American schools are falling behind. So physicists and mathematicians sort of put themselves forward and say, we will teach you how to make everything right again. In the 1960s, it's cognitive scientists. In the 1980s, a group of cognitive scientists aligns themselves with the scruffier disciplines to create what they call the learning sciences. But all the time, new actors come in and they draw on these tensions to make a claim about how they can do educational research better. Of course, what happens with MOOCs is that a new set of reformers who are animated by corporate data science and computer science entered into the space of educational research. These reformers put forth the proposition that analyzing the clickstream data of learners would revolutionize educational research. So this is a famous quote. For instance, this is a famous quote from the edX president, Anant Agarwal. And he famously said when MOOCs began, and this is sort of a very typical sort of hype statement, but I'm going to just analyze it because I think it says something interesting. And so when MOOCs began, Anant Agarwal famously said that all the schools in our consortium have access to all the data in the platform in an anonymized format. And this is the line which is interesting. This is what I call the particle accelerator of learning, big data in learning in real time. So this is, of course, a giant hype statement. But even if this is hype, I want to sort of point out the cultural work that this statement does. The particle accelerator line is the most vivid. And it seems to paint education research as similar to particle physics research, in that education research is about seeking out the educational equivalent of the Higgs boson, as well as other fundamental elements of learning. So the particle accelerator part sort of says, this way the clickstream data will help us get to the fundamental unit of learning, if you will. But the second half of the metaphor, big data in learning in real time, operates in a different register. So that part of the statement really refers to the world of corporate data science that is done in the workplaces of Facebook and Google. So a world where engineers and computer scientists use dashboards, analytic software, and A/B tests to maximize what they call engagement, right? So what this statement does, I think the cultural work it does, is that it takes a core tension that has always existed in educational research, like is it pure, is it applied, and then attempts to dissolve that tension by arguing that big data makes both pure and applied research possible. So it's like having your cake and eating it as well, right? Of course, this is hype, but still, it's good to start from the hype before we go to what people actually do. The earliest knowledge production work that came out of MOOCs was thus big data-driven observational analysis, whose main goal was to combat this dropout narrative. So what was this dropout narrative? So as the hype over MOOCs began, people started to notice that even though many learners started a MOOC, very few of them actually finished. This was often referred to as the problem of dropout or attrition. Critics often suggested that this is because these courses are low quality. So these courses are bad, they don't engage students, that's why people are dropping out. So in response, many early MOOC knowledge producers drew on sort of big data-driven observational analysis to show that dropout was simply not a sufficient description of what was happening in MOOCs. Rather, MOOC learners were kind of dipping in and out of material, and most of them simply did not want to finish a course in the traditional sense. So they were not there to finish a class, they were kind of there to learn what they wanted. So a lot of the early work, and this is one of the most famous cited papers that came out in 2012, has been cited more than 1,000 times. A lot of work that came out in this early period showed that you could classify learners into different types based on their activities. And so this is one of the most early papers. It classifies learners into 4 categories. Auditing, so those who engaged with the content but didn't complete the assessments. Completing, those who finished the assessments. Disengaging, those who started the early assessments but dropped out. And then sampling, people who just dip in and out and watch only the videos. And a lot of this early work, like this paper, showed that MOOC learners were a lot more complicated than people thought. And given the positionality of MOOC research between education, sort of computer science, and corporate data science, these papers often compared MOOC learners to other populations. For instance, YouTube viewers, Stack Exchange users, and then, interestingly enough, community college students who don't necessarily go to community college to get a degree, but rather sort of sample courses to get what they want. And they often don't finish in the traditional sense. So a lot of these early papers argued that we need to redefine what a course means, we need to define what completing means, and so on. But of course, correlation-driven analyses like these, and they were fairly interesting ones, can only take you so far, right? By 2015, the dropout debate had kind of died down, the hype over MOOCs also had kind of died down, and the limits of correlation-driven observational analyses were clear. This education researcher from Harvard called Justin Reich, he gave a talk in January 2015, and he summarized the research so far in this way. So this is from a slide that I saw during fieldwork. He said that most MOOC research so far, I don't know how visible this slide is, could be summarized under, and he called it Reich's law, but essentially he says all the research says so far is students who do stuff do more stuff. Students who do stuff do better than the students who don't do stuff. So conclusion, make students do more stuff, right? And he argued that, okay, at this point we've gotten all we can about how students do stuff. We have to do something different. And what was that something different? As always, and this will not surprise people here, the answer was that we have to do experiments, which is sort of always the answer that seems to come out of these debates, is we have to stop doing observational research, we have to do experiments because experiments are causal and we need causal frameworks, which is exactly what's happening today in psychology, economics, and sort of the same thing happened here all over again. So in that particular talk, he argued that educational MOOC researchers, but he came from education, should concentrate on what he called thick and causal claims. So what did he mean? So essentially, he gave this whole thing, and he said there are two axes of research. So there's thick research to thin research. So that's the y-axis. And there's observational research to causal research. So thin research was research that looked at learners superficially. Thick research was, and this is all quantitative research, so we're not talking Clifford Geertz here. Thick research was often the ones that looked at learners' activities in a more detailed way. Observational research was sort of big data driven analytical research, and of course causal research was experiments. So what he argued was that we've been doing all three kinds of research. We've been doing observational and thick research. We've been doing observational and thin research. We've also been doing thin and causal research because of behavioral psychology. What we really need to do, he says, was thick and causal research. What did he mean by that? What he meant by that was what you need, and this is sort of a refrain you often hear in educational research over and over again, is that what you need is really particular research in particular subject matter areas. So you need to have teams of people, you know, a physics instructor, a physics curriculum developer, maybe a data scientist or two, and you need to actually find out how people learn physics, like get into all the nitty-gritties, no big picture psychology experiments on motivation, get into the real teaching. So this is the kind of work we need to do, he says, but it's hard to do because people don't like to collaborate. This was sort of the refrain he put forward, but he also argued this is where we need to go. So this is from the educational research side. But the other people who are involved in MOOC research, sort of who came from corporate data science or computer science, argued that that's not what the need of the hour is. What the need of the hour is practical theory built into software. So this is almost the complete opposite of what the educational researcher is arguing for. This group of people, computer scientists, argued that MOOC research needed more practical theory built into software. So this is a slide from the computer scientist Scott Clemmer. Again, he used this slide in a conference that I attended. So here, what he says in the slide, again, is, I know this slide is a bit blurry. It comes out of a picture I took during fieldwork. But he says MOOC research is a great CS opportunity. It's a great research opportunity. But the need of the hour is to build practical theory, and I like this term, practical theory, with real-world experiments that can scale. And by practical theory, if you build practical theory, you can bake the pedagogy into the software that transforms learning. So this is a completely opposite picture of research. It's not thick and causal research. It's really very thin but very, very scalable research that can sort of be built into the software, bake the pedagogy into software to transform learning. These sort of two different priorities of educational researchers versus computer scientists map to 4 fault lines of MOOC knowledge production: deduction versus induction as methods of research, explanation versus prediction as outcomes of research, the pursuit of generalizable or scalable knowledge claims versus particular knowledge claims, and finally, the tension between making knowledge and building software. Experts who appear on one side of these fault lines, so people who appear on the right-hand side, that is, those who prefer inductive to deductive knowledge, predictive to explanatory outcomes, more generalizable and scalable knowledge to particular knowledge, and often sort of are much more involved in the intricacies of software design. In my field work, we're often far more likely to identify as data scientists and draw on the rhetoric of big data. So it wasn't that the data scientists were a thing by themselves. It was a position people took, but it often emerged out of these sorts of contests that were happening in MOOC research. In other words, the expert knowledge producers who can draw on the resources of all 3 fields that intersect in MOOC research instrumentally and can move fluidly between them are most likely to label themselves as data scientists. And in order to do so, I argue that these experts have to use the cultural vocabularies native to computer science and corporate data science of understanding other experts as users or domain experts. So to become a data scientist, you had to sort of use this culture, do this cultural work of casting the other people in your field, in your workplace, as either users or domain experts. And that often came down to people who were on the right-hand side of those 4 fault lines. So let me take one example that has proved very influential in the world of MOOC research, as well as in the broader MOOC ecosystem. This was a study that was published in 2014. It's called How Video Production Affects Student Engagement, an empirical study of MOOC videos. It was written by 2 computer scientists during a summer internship with edX. And it's an observational style analysis, so it was produced in the heyday of the dropout debate. It's an observational style analysis of 7 million video sessions of 862 videos from 4 edX courses. So this is a classic sort of big data analysis. It looks at how long learners stayed engaged in the video. That is, how much of the video did they watch before they got bored or moved on to something else or what have you, right? So the researchers find, and I already put it here, I guess, is that shorter videos are much more engaging, that informal talking head videos are more engaging, that Khan style, meaning the Khan Academy, Khan style tablet drawings are more engaging, and that even high quality pre-recorded classroom lectures might not make for engaging online videos. And students engage differently with lecture and tutorial videos. So one way this study works is that it's a series of statistical graphs with a recommendation for each observational finding. So the first graph, and again, I don't know if this is clear, what it shows is that there's a drop-off around the 6th minute of the video, there's a drop-off. So if you look at the red lines, there's a steep fall. And it maps to the very, this used to drive other people in the field mad, to this sort of recommendation that, you know what, you just need to make the videos less than 6 minutes. The second graph shows a different kind of drop-off. So here, it's for pre-produced videos versus videos which were sort of recorded for something else and then used in a MOOC. And it shows that for pre-produced videos, the drop-off is less than it is for videos that have been made for some other purpose, which of course maps to the recommendation that always plan for the MOOC format, even for live lectures. So as you can tell, this is a classic sort of study. The analysis is inductive, predictive rather than explanatory, and the findings are often used to feed directly into the software design. I guess. Yet, the authors of this paper also configure the other experts on MOOC videos. So there are 2 other experts involved, the instructors and the video producers, as both domain experts and users simultaneously. So the video producers are situated in the paper as domain experts, who give explanations for what the data analysis found. So the video producers are often the ones who are asked to explain why engagement drops after 6 minutes. And then strikingly, the paper also portrays them as users whose beliefs have now been validated by a data-driven analysis. Instructors appear in this paper as users of the author's recommendations for engaging videos. Then the authors suggest that the study has verified the intuitions of the instructors and the video producers, who can now use this analysis to show others that they were right all along, right? Tellingly, the expertise of the authors, who have sort of taken a data scientist role, is left undefined, right? So everybody else is given an area of expertise, but the authors themselves don't have they are just data experts, essentially. But even that is not quite said, right? How video production affects student engagement had very different receptions from educational researchers and the edX management. The educational researchers argued that the study was flawed because it generalized too much and it lacked explanations. Moreover, they argued that video producers were the wrong domain experts for the job, and the domain experts in question should have been educational researchers themselves. But in even articulating this particular criticism, the educational researchers essentially reflected back the roles that the data scientists had assigned other experts. So even in this criticism, they were saying, you just chose the wrong domain experts. We should have been the domain experts you should have chosen. So there was a lot of critique from one side. The edX management, however, embraced the finding. And it is now part of the edX documentation. So even now, if you go to the edX how-to documentation and they give best practice instructions and so on, you will see this prominently. Videos should be no longer than 6 to 9 minutes. This is obviously a recommendation. Nobody is forcing anybody to do anything. But even now, sort of 6 years after that study, this is still there, right? So this was embraced by the edX management. So to sort of return to the question I started off with, what accounts for the power of data scientists, and why is this role something that is technically feasible and culturally desirable? What I suggest here is that by drawing on the cultural vocabulary of users and domain experts, the data scientists were able to dictate the terms of participation to the other experts in the field. So my claim here is not that data scientists are different, it's a thing in itself, but that it is precisely how a group of experts situate themselves in relation to other experts that makes them into a data scientist. So in the final section of my talk, very short, I'll argue, and this is the most speculative part of this talk, I'll argue that data science is a case of a broader form of expertise that I call platform expertise. So data scientist was not the only way my informants in the field referred to themselves. Broadly, in addition to calling themselves computer scientists or learning scientists or educational researchers, my informants also used a wide variety of new terms to refer to themselves, one of which was data scientists, but they also called themselves platform designers, design thinkers, and learning engineers. All these terms, I suggest, are indicative of an emerging form of expertise that is contingent on the instrumentality of digital platforms. This emerging form of expertise makes more data science technically feasible and culturally desirable, and I'm going to call, so data science is, I think, part of a general trend that is emerging that I call platform expertise. So what is platform expertise? I'll sort of suggest, and I'm still working through some of these things, I suggest that platform expertise is neither abstract knowledge nor is it a method. Rather, it's a set of normative logics that are tied to Silicon Valley workplaces. So some examples of these normative logics are a preference for fast, iterative production processes, or what software engineers call agile, the agile style of building software, this sort of preference for data-driven decision-making, whatever that is, and a preference for scalability. Platform experts are both hybrid experts and experts of hybridity, just like data scientists, who can fluidly move between inductive and deductive methods, predictive and explanatory knowledge, and between knowledge and software. And they make this hybridity very central to their own position in particular workplaces. On the question of which experts get to take on the platform expert role, I argue, or I speculate rather, that there are two key factors: the status of domain expertise and an institution's openness to outside logics. So for instance, in high status and highly regulated domains like medicine, platform experts in some sense will always be subordinate to domain experts. Or to put it differently, the people who get to be platform experts have to come from within the domain. They probably, outsiders won't be able to take on that role. So data scientists in medicine or physics or biology remain technicians who are not able to dictate the terms of participation to other experts. That could change, but it would probably have to come from within that particular institution. I mean, this is a prediction. One shouldn't offer predictions, but that's sort of where my thinking is going. On the other hand, in low status domains, education being the primary one, that was my field of study, that are porous to outsiders, platform experts can dictate the terms of participation to domain experts. So the less the status of the domain expertise and the more its openness to outsiders, the more susceptible an institution is to platform expertise, which becomes a way for reformers within the institution to change the way the institution works. So to conclude, the last part was a little speculative, but so what I wanted to argue today was I wanted to answer the question, what accounts for the power of data scientists and why is this form of expertise culturally desirable today? I argued that the power of data scientists comes from their ability to configure other experts as collaborators, domain experts, and users, and to move between these registers seamlessly and simultaneously. Data scientists are thus hybrid experts and experts of hybridity. The role of data scientist is a relationally defined role. Experts who are able to move between these registers are more likely to sort of identify as data scientists. Finally, I tried to suggest that data science is a form of expertise. It's a form of a broader emerging form of expertise that I call platform expertise, which is a set of normative logics that originated in Silicon Valley workplaces that are being imported into other institutions by reformers in those institutions. I'll stop here, and please, if you have questions, I'd love to. Thank you.